example we're going to do here is going to be example 10. And back in example 9, all of our roots had the same magnitude, because they all had a magnitude of 1, and obliquely spaced about the unit circle if you were to draw them out. We have to also look at complex roots that may occur in pairs. So you may end up getting, like a 2 plus a 3i, or a 6 minus a 7i, or something like that. So those are pairs of solution, or conjugate pairs for your roots. So these are called nth roots of unity when you have n distinct nth roots. So we're going to look for finding the 3 cube roots of z equals -6 plus 6i. So we're going to solve this basically the same way we just did the last problem. First, you need to write your z in trig form. So when we do that, if we start off with we actually have this ends up being a -6, 6. So we need to find our r value, which gives us -6 squared plus 6 squared, which is a radical 72, which we've reduced in the past, comes down to a 6 radical 2. Now we also need to figure out our theta. So if we take the arctangent of a 6 over -6, that is arctangent of -1. Now this is going to spit out a negative 45 degrees, but because it is -6, 6, that means you go to the left 6, up 6, you're going to be in quadrant 2. That means that you're going to have to take 180 degrees minus 45. So your actual theta is going to end up being 135 degrees. Or, if you want to put that in terms of pi, that is a 5, or sorry, not a 5 pi over 4. Let me get rid of that 5 here. That's a 3 pi over 4. So there is your theta. There is your r value. So the second step is we need to find the form of the roots. So we need to find the form, and that is where we use the formula that is given to you. So that's this formula back here with that we have to use right here. And so we're going to get the cosine of, or sorry, the third root, because we're trying to find 3. So the third root of your 6 radical 2. Ugh. It's not going to be very pretty. And then that's going to be times your cosine of the 3 pi over 4. That's your theta. Plus 2 pi k all over 3 plus I sine of 3 pi over 4 plus 2 pi k. And since we can't really combine 2 pi k into 3 pi over 4, this is going to be the ugly form you are going to need to use. Alright, so let's move on to finding all of our roots. So for k values of 0, 1, and 2, we need to find our roots. So when k is equal to 0, k is equal to 0, you have to plug in a 0 for your k, so that's going to be a third root of 6 radical 2, yeah, that's going to be nice and pretty, times the cosine of, plug a 0 in for 2 pi k, that's just a 2 pi times 0, which is just gone. So you have a 3 pi over 4 divided by 3, plus the sign is going to be the same. So you're going to have 3 pi over 4 divided by 3. So when we plug these values into your calculator, you're actually going to get something kind of ugly. We're going to get a third root of 6 radical 2, and when you multiply top and or when you divide 3 pi over 4 by 3, that's just going to be the cosine of 3 pi over 4 plus I sine of 3 pi over 4. And what it let you do in this case is we'll let you turn these into decimals. Your actual root ends up becoming 1.44. That's what you get when you distribute this through your cosine, plus and 1.44 I. 1.44 I. There we go. So the next thing you need to do is you need to plug in your values for k equals 1. You have to plug in your values for k equals 2. And when you plug those in, you have to be very careful with what you are substituting in as you go along, like this. You should end up getting, for k equals 1, a negative 1.9701 plus 0. I guess I should just round to 2 decimals and go 0.59 I. And when you get k equals 2, you're going to plug in these values. You get a 0.53 plus, or actually this should be a minus, minus 1.97 I. So your three solutions end up being, there's one when k equals 0, there's one when k equals 1, and here's one when k equals 2. So good luck on your homework. Make sure you ask me questions when you get them. Kline out.